Hi, today we are going to look at how to express derived quantity in dimensional form. In other words, we'll express derived quantities in three basic forms. That is in terms of what? Length, mass, and time. Look at what we have here. We say the derived quantities in terms of in dimensional form. We have mass. In dimensional form is expressed as capital letter N. The length is expressed with symbol. We have capital letter L. Then time we use for capital letter T. So how do we use this information to express derived quantities in dimensional form? Let's take a typical example of derived quantity. One typical example. We have the area which we express as length times what? The width, and the SI unit of length is meter square. Why? Because the length is the unit for length is what? Is meters. The unit for the width is what? Meters. So meters multiplied by meters will give us what? Meter square. So in dimensional form, area will replace this letter N with what? With letter L. So in dimensional form, area is what? L squared. Let's look at the volume in dimensional form. The volume in SI units is cubic meter. In dimensional form, we have L raised to power 3. Let's look at velocity in dimensional form. Let's express velocity in dimensional form. We say velocity in SI units, the SI unit of velocity is meter per second. So let's express it in dimensional form. In dimensional form, L here becomes L, X we have what? T. So velocity in dimensional form is L per what? Per T. Or you can express it in exponential form, which we have LT raised to power 1. So let's look at acceleration. We say acceleration is what? Changing velocity with time. Velocity with time. So what is the dimension? How do we express velocity in dimensional form? Already we said velocity is expressed in dimensional form as L all over T. So let's replace what? The numerator here, which is the velocity, with L over T. Remember, L over T is what? Is the velocity. Then let's look at the denominator, which have the time. So how do we express time? Time we use what? Capital letter T here. So we have L over T divided by what? Time. So if you express it, it's the same thing as L T divided by T over 1. And when you change division to multiplication, what happened? We have L over T multiplied by 1 all over T. Are we together? So the what? In dimensional form, acceleration now can be expressed as L over what? T squared. In exponential form is L T raised to power minus 2. Lt raised to power minus 2. That is the dimensional form of acceleration. Let's look at force. Let's express force in dimensional form. We say force is the product of mass and acceleration. Force is the product of mass and acceleration. What is the dimensional form of mass? We use capital letter M. Acceleration, from our previous work here, we say acceleration in dimensional form is L all over T squared. So we multiply this. A here becomes what? Since it's acceleration, we have all over T squared. So M multiplied by L, we have M L all over what? T squared. In exponential form, it's ML T raised to power minus 2. This is the dimensional way of expressing what? Force of a body. That's the dimensional form of expressing the force of a body.